The purpose of today's lesson is to understand how to graph and write linear equations using what's called the point-slope form. Now, if you might recall, if you were given 2 points that were on a line, you could write the equation of that line in what's called slope-intercept form. And what you did is you would find first the slope of the line using your slope formula, y1 minus y2 over x1 minus x2. Remember, you could always flip the order that this is in. So using those 2 points, we find that the slope of this line measures 6. So therefore, we could write y equals 6x plus b. We need to find b. We can insert any of these 2 points using their x and y values in, and that we find that b in this example is negative 13, so that we could write our final answer is y equals 6x minus 13. And that's a very helpful form to use because we can then use the slope and the y-intercept to graph that line. And as we just did above, you might recall the formula is m equals, and again, whether it's y2 minus y1 or the other way around, as long as you don't mix up the x and the y's. If you start with 2, you're going to start with the 2 down there. Okay, now, can we write this equation in another form? Well, if you think about it, this equation is really a proportion. And if you think about m being over 1, as in any proportion, you can cross multiply. y2 minus y1 equals the slope times x2 minus x1. And what that is, in essence, is what's called the point-slope form. And the reason it's called point-slope form is that all you need is the slope and 1 point to be able to write it. And instead of using y2, we're going to just use y minus y1. And the reason is that x1, y1 is a specific point. And xy is a place saver for any point on the line. Similar to when you write y equals mx plus b, that's what you do. Okay? This is very helpful, and the reason we teach this other method is if the y-intercept is not an integer, okay, this is a little bit easier to do. So, let's do slope and point-slope form. A line passes through the point negative 3, 6 and has a slope of negative 5. What is the equation of this line in point-slope form? So, my formula, y minus y1 equals m times x minus x1. The thing you have to be very careful about is the changing of signs, and that's the most common mistake students will make, because the formula is a minus. So, if you look here, I have y1, and I'll put it here, x1, y1 is 6, so it's y minus 6. Slope is negative 5, x, since it's negative 3, negative 3 becomes a positive. All right? So that's the one thing you have to be very careful about when doing this. Now, you'll also see how easy it is to graph this equation. If the formula or the equation in point-slope form is y minus 1 is equal to 2/3 parentheses x minus 2, that means my coordinate is 2, 1. Okay? So 2, 1 is my coordinate. And as we've done before, we'll use our slope of 2/3, rise over run, to find the second point. And now we can graph that line. Okay? Now we want to write the equation of the line graphed below in point-slope form. Well, I can use any of these 3 points. All right? I can use negative 1, 1. I can use 2, 3. And I can even use 5, 5. Doesn't matter. All right? But what I do know is that my slope is up to the right 3. All right? So I'm going to use the first one here. Make this x1, y1. Y minus 1 is equal to 2/3 parentheses x plus 1. Okay? One of the other things you'll see, what's interesting about the point slope form, excuse me, is that you can have many equations. So for example, I could have also written y minus 3 equals 2/3 x minus 2. So there's many point slope forms that I can have of the same equation, or the same line. But there's only one slope-intercept form because there's only one slope and y-intercept. Okay? So let's go to another example. The table below shows the descent of a hot air balloon. So if you look here, if I take the difference between any 2 points, I find my slope. So my slope is negative 50 over 20, which is negative 2.5. Now, that works no matter which 2 points, because over here is 40, but then this is minus 100. So it's still, even though the numbers are different, the rate of change is the same. Okay, so now I want to write my equation. Y minus 640 equals negative 2.5 times x minus 10. And now, if I want to write this in slope-intercept form, what I would do is solve it. Because now I would figure out, because the helpfulness of this is what this tells me is negative 2.5 is the rate of descent per second, feet per second. And the 665 represents the initial altitude. Okay. What is the slope in 1 point on this line? The slope, 4/9, and one of the points is negative 7, 12. All right. And then our last example. Mindy said the equation of the line that passes through the point 3, 4 with a slope of 6 is y minus 4 equals 6 times x plus 3. Is she correct? And the answer is no. She switched the signs. It should be y plus 4 equals 6 times x minus 3. Okay? Now, you can always check your answer to this. And how can you check? Well, if you figure out, if the slope is 6, and one of the points on the line is 3, negative 4, well, a second point on that line, by going up 6 and to the right 1, is the point 4, 2. Okay? And if you plug in 4 for x, x, and 2 for y, then the numbers should work. And you see they do, which wouldn't occur in the equation up at the top. Okay? So that's a way to double check that you have written your point slope form correctly. Okay? So point slope form As you've seen, we've come up with a couple of different ways to write the equation of a line. We've seen standard form, ax plus by equals c. We've seen slope-intercept form, y equals mx plus b. And then today we've done point-slope form.